Hello everyone, welcome back to another episode of Classic Arcade Repairs. Sean here with you. I am in the process, as our Canadian brothers say, I'm in the process of repairing an asteroids game pretty much. All of the electronics were sent to me. This was a asteroids that had been sitting for like 25 years. And I got the board, I got the power supply, and I got the monitor. But I did not get the monitor tube. I just got the electronics. It's a G05-801, which you can tell by the big caps. And I've already repaired the board off camera. I did not film it, but I'll tell you what was wrong with it. It needed all new sockets, and it had no Y deflection, so I replaced the amps in the Y circuit. It had a blown out negative 15 volt regulator. It was putting straight input voltage through to the output. And I imagine that's what blew up the amps, maybe. I'm not sure. Those amps probably can handle that voltage on the rail. But anyway, one of the amps was blown out, so I just replaced both of them in that circuit. I replaced all the electrolytics. All the regulators, of course. And I think that's all I remember. Oh, no, it had two bad RAMs in the vector RAMs. I had two bad vector RAMs. Okay, so that's that. And the power supply was BAD, bad. So new caps, I put new caps in it. The pass transistor was open in it. So I put a new one of those in there, a 3055. I replaced the driver transistor just for the heck of it. It had no sound, so I had to replace both amps. This resistor was burnt up, so I replaced that blue metal film resistor there. I replaced the 0.1 microfarad caps. They were the big green, the old green ones. I just went ahead and replaced them. And that's it. Now it works perfect. Yeah, and the solder was really terrible on it. On the connectors, I had to resolder all of the connections. I have a ground strap on right here. This early version of the AR with asteroids has a sound on signal, or it's just ground from the board. I don't know, but that pin has to be grounded in order to get sound. So I just ground it out. I'll remove that before I ship it back. But this was, you know, it did the run test. It's done good. Works great. Sounds great. Works great. 5 volts is perfect. Good to go. So that's that. The board and the power supply are already done. This guy here, I just had to make this harness. I had to make a harness to plug into my harness to plug in the 805. With that vector monitor, I can just plug it straight into this. But the 805 is different. It's not compatible. So I had to make the wiring for it. Yeah. And I kind of just got this. I tested all 4 of these transistors, and they tested good. The deflection transistors. And I've got it all hooked up. Yeah, I had to make this harness and the power input harness for this thing. But if I fire it up and turn it on, you'll see what it does. It doesn't do much of nothing. It's got signs of life. And you know what? Let's do this. First, let me turn it off. I'm going to put this on current limit. Okay? And you'll see this comes on, but it's not very bright. Let me turn it on. It's on current limit. And that might look brighter in the camera. It does actually in the viewfinder. It looks pretty bright. But that is pretty dim, to be honest. So that tells me that there are no shorts because it's nice and dim. So I'm just going to hit bypass, and they go off and the monitor will come on. You see net glow there. Okay, and this is what this monitor does. Not much. But I like that it does show signs of life, so we'll go through. I haven't touched this deflection board. I bet you it's got cracked solder joints everywhere on it. I haven't touched any of this. So that's what it's doing. Just kind of that. So let's just go ahead and turn it off. Okay. So when I take this apart and get it all apart, I'll show you the harness that I had to make. I'll kind of go over that. And I got my notes here that I had to make. I pulled the manual for the 801, the G05-801, and I got all the information. There wasn't a wiring diagram, so I had to kind of make my own wiring diagram of what's what, you know. Yeah. And what I did was I used an existing, I had this tube and frame came to me from a friend that I do business with. And all it had was the harness. That's all that was. It was just a tube with a harness. Well, I used that existing harness and adapted it with all of this. So I just had to change a few wires around on that. I had to add some wires. And yeah, so got it good to go. And being that it was, this is originally out of a Wells Gardner V2000, the yoke plugged right into this. You know, that was the only universal part was the yoke. So, yeah. Okay. But we're going to do a good clean up and rebuild on this. Get it right. Recap. Clean it up. Yeah, go from there. Now let me get this thing down off the bench and cleaned up and get these boards out of the way, and I'll show you this harness. And then start repairing this thing, kind of freshening it up. Make sure, you know, since we didn't have deflection all over, I want to check these pre-drivers and stuff and all that. I know these are good. I tested them. They're getting replaced anyway. I'm upgrading to better transistors. These 3792 and 3716s are pretty weak. They're on the weak side. So yeah, we're putting a much more stout transistor in this thing so that it'll last for the long haul. Yeah, so alright, I'll be back. I will be back. Okay, so this is the harness that I had to make. This is the adapter basically for if you have a 1980-81 asteroids, Omega Race would work. Anything that uses the Wells V2000 or the 805 G05-802, you would need this adapter if you were going to use a G05-801 early Electrohome like this. You would need this adapter that plugs into the harness and then breaks out to plug into the monitor. So you have your X, Y, Z information here and all your power information, your power here, your AC inputs. So that's this guy. And then this is the adapted V2000 harness that I used. I cleaned it up, I washed it. I didn't want to be messing with anything really nasty dirty. And just repinned it. It had those red junk connectors on it, so I repinned it and put new connectors on it and keyed them and labeled them. This is P900, that goes to the high voltage cage, and this goes to the deflection board and is P501. That's to the cathode and grid for this. And then this is deflection board P7000. It looks like voltage for the deflection board. And then this goes off and over to the power supply board, the rectifier board. Yeah, so. Yep. Well, that is that. And I have the two 6.3 volt lines run all the way up and then coming back down through here, up through here, and then back down and over to here. So as not to have it just jumped from here to here, I've got it going the whole length of the thing. Yeah, kind of nicely done. So that's my G05-801 adapter. Right there. You know, if I don't have the monitor itself. This is my adapter for the power, or for the harness, for my harness. This just will directly plug into the 801. So that's that stuff. So we're going to get this, we'll start with the deflection board and look at that and yeah, make sure that it's good to go. I'm sure it's got cracked solder joints everywhere and needs caps and stuff like that, so I'll do that board first. Yeah, these connectors are really bad. The solder on them are pretty darn bad. If we look at this one right here in the center, which is the yoke connection. No, it's not that, is it? Right there. See that crack? That one's cracked. You know, somebody soldered this. One of the deflection inputs, but not the other one. Cracked. We got a connector up here. Oh, that one looks cracked along the base. Yeah. Not a bad solder joints on here. Crack-a-doodle-doo. We have a 47, it's actually 47 microfarad. It's a 125 volt cap, so we'll do a whatever I've got. I probably got a 47 at 250. Put that in there. These are 470 at 50. I got those. And that's it. And I tested all of these, you know, the pre-drivers, and they all test good. They seem fine. So I didn't see anything open. So should be good to go. We'll just change the caps, resolder a lot of this board, and this thing should be good to go. All right, I got some stuff. It's like Christmas over here. What did I buy? 7908, 1.5 amp, negative 8 volt, negative 8? Yeah, negative 8 volt regulator, 1.5 amp, 9 volt regulator, 18,000 microfarad, 18,000 microfarad, 18,000 microfarad. These two are 35 volts and this one is 16 volts. And those are for a Condor power supply. Cinematronics Condor power supply. That's what those were ordered for. And I got my capacitors for the vector monitor. Now these are 6800 at 50, and these originals are 7200 at 50. Now I know that this monitor is not pulling more than 3 amps of power. I know that because I had 3 amps up in my current limiting and I was running it perfectly on a 3 amp limited supply. So I'm figuring that 6800 microfarads of capacitance on the negative and positive 25 volt rails is going to be just fine. So I got 6800s because 7200s or 8000s or whatever, they were just more expensive. So I just went with those, and these are good caps. These are good Nichicon caps. I bought 2 pass transistors just to put in stock. I replaced 2 N3055s with these on semiconductor. And these are deflection transistors for vector monitors. These replaced the 2 N3716 and 27. Let me try that again. These replace the 2N3716 and the 2N3792. It is the MJ15003G, that's the NPN transistor, and the PNP is MJ15004G. These are 250 watt power dissipation parts, 20 amp continuous current. So they are a much upgraded transistor for the regular ones. About 100 more watts of power dissipation to deal with heat. So that's that. I have put these guys on here. These are basically complementary Darlington transistors. This is the 2N6050. This is a 2N6052. And I took them off. I cleaned them up really good. Put new insulators and new paste between them and the heatsink. So those are good to go, and they're tested, they're good. And the caps will go right there, of course. And I've got this thing cleaned up and redone. I cleaned the fuses, so that's good to go. The deflection PCB, I have the caps replaced. Okay. I resoldered the entire board because I was not happy with how this board looked. So I resoldered every joint on here that was not one of these. These joints right here were good. They were in the, you know how they're in the little rivet holes or whatever. I didn't do those necessarily. If they looked like they needed, I did. But I reflowed the solder on every through-hole part on here. So that is good to go. So I'll go ahead, put the caps in this. Oh, and I got through connectors for that, whatchamacallit, Seawolf 2 board. Remember these? This is from Arcade Parts and Repair. Remember, I got to replace those broken ones for this board. Seawolf 2. I got those as well. So we'll be finishing a couple jobs today. I'm going to go ahead and sort this stuff out, put it into stock. I need 2 more of these because I did replace 2 of them on here. I'm just upgrading these deflection output transistors. I got one side done with the NPN and the PNP all done, and now I'll do this side. And these are tested good, these parts are, but I'm just going to take them out. I'm going to clean them up, and I put them in a bag as good. They're used, they're good, but the idea is to put this thing together with better parts. I've already repinned these. These have been repinned, both of them. So I'll replace these, clean it up and replace, and we'll have nice, new, high quality current amplification transistors here. And then I'll have one NPN and one PNP left over for just stock. These things are not cheap. These are a $10 a piece part. So, but worth it. In my book, they're worth it. It's worth it to get good quality parts. So, I'll go ahead and do that work, and we'll put this monitor back up on here and see what we get. Alright, these two pieces are done. We got our NPN and PNP transistors, new mica insulators, tons of paste, heat sink compound. Make sure we're getting a good thermal connection. New pins, Trifurcan pins. This thing has its new caps. They're screw caps, so you have to just kind of work with it. There we go. Positive side, positive side. Good to go. So we are done with this. Now I can put it back together. Here's the old 3792 and 3716. Those will just go into a bag as a pair. And who knows? I don't know. Yeah, so. And these things, I tried charging these things up and then doing the light bulb trick. These caps won't even hold a charge. And this one actually looks like the little vent cover blew off. So I think these caps are pretty shot, these guys right here. So, alright, let's go ahead, hook this thing up, hook the board up how I had it, and see what we get. Okay, we're all hooked up. Got deflection amps plugged in. I got like a piece of foam under here, so this is sitting on a piece of foam. Neck, yoke, deflection, everything's hooked up. I got it in current limit. So we be limiting current. Yeah, so let's go ahead and fire it up. Yeah, everything's there. It's all good. Here we go. Limiting current. They should be somewhat dim. And just as they are just somewhat dim. Not full on bright, which is good. That's how it should be. So we're safe to go ahead and bypass the current limit. And we'll see what's happening. It looks like the same thing that was before. And it's the same nonsense. Huh. Very weird. Okay, interesting. Okay, yeah, I do not know what to think about this. I wish I had a better setup for this, but I don't. So, okay, let me, I'm going to have to, maybe my setup isn't quite right. I don't know exactly what's going on. So let me do a little research and look over my setup. Maybe this tube isn't any good. I don't know anything about this tube. So, all right, yeah, let me look into some things and I'll come back. All right, I just took some voltage readings and I got 26 volts on the NPN transistors on here. And I got like 7 volts on the PNP transistors, -7. So, yeah, there's something not right with the, it's just something not right with that. I'm going to have to figure out what's going on. Do I have everything wired up correctly? Let me, yeah, go back to it and find out what is going on, or do we have bad transistors on here? So, yeah, I don't know. I don't know yet. We're going to figure it out, though. All right, I'll be back. I have figured out the issue. If I put this on the minus rail on the power supply, I'm basically running 0.6 of an amp through these here from the negative supply, and I can kind of prop this like so. Maybe. There we go. And if I turn it on, it's on ground and the negative 25 volt supply. Let's turn it on. This is what I get. 1.78 volts at the load. But if I take and I remove this, and then I take this and I measure at the power supply without a load, minus 26.75. Back at the load. Okay, we got nothing here right now, and I'll plug this back in to the load, to the power supply. This is the ground line, or the other line. And we get negative 1.7. The power supply is no good. So if I look at the negative supply, right here's the negative. Okay, it comes over. There's a diode right there. I don't think that's an issue. I think this guy's the problem. And what's funny about it is I tested this and it seemed to be okay. I'm going to retest it. It's not my cap. I know my cap's fine. The fact that it's good with no load and then you put a load on it and it kills it tells me that it's the current amp right here. This current amp. I mean, it might be a bad socket. This TL3 socket might be no good. I'm going to go ahead and remove that transistor and give it another test and just replace it. I'm just going to go ahead and replace it and see what happens. But I think it's something to do with that. It's either a bad transistor, a bad socket, something like that. Let me go ahead and take a look. Yeah, and by the way, this is I'm hooked up now to the positive 25 volt rail. And at the load, measuring at the load, I got 26.4 volts. So yeah, the positive side is fine, and that's getting really super hot. But yeah, the positive side is fine. It's the negative side, it's dead. So I'll go ahead and get that figured out. Yeah, kind of some strangeness going on. I took this transistor off and looked at it with the meter, with the diode test and everything, and it looks okay to me. So I put it back in. I don't think that's the problem. Then I came to the bridge rectifier and started probing around on the bridge rectifier. And let's see if I can do this. The negative, if I go to this AC, I get 493, right? If I can get on it, 493, and then if I go to the other AC, I get 480. And that's for the positive. So remember, it was like 483 and 4... Come on, what this damn glare? Right? 483 and 470 or something like that. So now if I check the negative, go to AC here. See how it's higher? 525. That kind of is a little... And then this one is... Boy, this is tough to do one-handed. 475. That one being up near 525 or whatever it was. All the other ones are around 4.7 or 470. And then the one is higher, and it's on the negative rail. So it's kind of got me wondering if it's the bridge. I'm going to remove the bridge rectifier, because I think that it could possibly be the problem. So yeah, maybe it's kind of open on one of the diodes. We're going to give that a shot, because I think that might be the whole issue. Possibly. It's possible. So we'll see. All right, well, I replaced the bridge, and I replaced the two diodes down there. I believe they're just kind of current protection, backfeed protection diodes. I went ahead and replaced those. See them underneath there? I replaced those two guys. And I'm getting the same thing on the negative. So I think it's that transistor. And I'm hoping it wasn't going to be that, because I'm still getting just the 1.7 volts on the negative rail. Yeah, let's turn it off. Unfortunately, it's looking like it's this. It's testing okay, but it's just dying under a load, I believe. It's not, it's something's internally wrong with it, and under a load, it's no good. So I'm going to have to order one of those, because I don't have any. Someone wants in. What are you doing? What are you doing out there making a racket? Yeah. Well, hello. Hello. Making all kind of racket out there trying to get in. Yeah, so unfortunately I don't have any of those. I'm going to replace both of them. I'm going to go ahead and I'm going to upgrade both of them. Goodness gracious, that's another, it's another order. I got to order more parts, so. All right, I mean, what can you do? Yeah. I don't have any PNP Darlingtons, and that's what that is. This is the NPN, and I can upgrade that with the 2N6059, which I have. But I do not have the PNP equivalent. Complementary transistor, I don't have it. So I am going to order from Mouser. And you know what? While I'm at it, I'm going to order 2 new TO3 sockets for this. Just for good measure, because they're cheap. So I'm going to do that, and goodness gracious, we'll put this one on hold. And I'll see you back when I get those parts. Okay, I got my order in from Mouser Electronics. Back at this G05-801. And let's see what I've got. Alright, here we have, this box is a bit overkill for one part. I'm pretty sure it's only one part. Yep, that is my Darlington amp PNP variety. Okay. Next, and this is Darlington amp NPN variety. Those are the 2 transistors for this power supply. And I believe I ordered maybe a couple just regular pass transistors for power supplies. Yeah, just one. This is a... Oh no, this is a MG05-004G. This is PNP vector transistor, basically. Okay, and then we got another little box here. Okay, and this is the NPN equivalent. Okay. Here I bought some TO3 sockets. Very nice. Oops. These are 22 microfarad. 22 microfarad at 35 volts is what those are. Goodness gracious. This is a 2N3773. That's a pass transistor right there for use in place of the 2N3055. It's a much better part. It's key to get those transistors. It's key to get ones that have a higher power dissipation, because those are used in the linear range, which means they're used almost as a big resistor, like a big rheostat or something. You know, the base current is turned up and turns them on based on the current that's being needed, and it turns these things on, and they're used as a resistor. That's why they heat up so much. So if you can get these with more power dissipation, they're just better, way better. So that's why I get this one. dissipates like 100 more watts of power than the 3055. This has like a 250 watt rating or something like that maybe, whereas the 3055 has maybe 150 watts or something like that. So it's a much better part. Here we have, I have no idea, what is this? Oh, I bought some more UA723 voltage controllers because I've been using a lot of those lately, so I bought a few more. And I bought some pots. These are $1K pots. Just 3 terminal pots. $1K. There. I'm going to go ahead. I always keep these bags. Oh, there's another one in there. I always keep these bags. So I'm going to put all these parts away, and then we'll get back to that. Power supply. Okay, well, have to make a little change of plans. Not really, but these beefed up transistors that I got. Remember, these are 50 amp. 300 watt Darlingtons, PNP NPN pair. The posts are bigger than normal, so I had to actually break the sockets. I'm leaving the collector pin, but I'm going to have to solder to the pins themselves. So I got me some new wire. I'm going to strip and wrap around those and solder it, and then put it into the board. So you have to do it a little different, but these things are the bomb. They're going to be great. So, all right, let me go ahead and do that, put this together, and I'll come back when it's all done. Okay, and I had to make you want to make a good solder connection, kind of loop your wires around there and make sure you get a good, proper solder connection on these power transistors. So now I'll go ahead and put this into the board. I gotta clean the solder out of these holes. Let me do that. Put this back on there. Put the corresponding. The yellow wire is the base on each of them, and the green is the emitter. And red, of course, is the collector. I'll put those in the corresponding spots, and this thing should be good to go. All right, we are all connected back up. And cleaned up, and as you can see, I've got it ready to go. Cleaned up the bottom of the board good. And yeah, I made a little mess of the bridge. Yeah, happens. Even I destroy stuff. So don't feel bad when you do. Alright, I have this hooked up on the -25 rail. I'm going to put this up here, and we will check out the I wish I had a pencil thin mustache, and I could solve some mysteries too. Alright, let's take a look at our see what Faulty Dan tells us. I'm going to go ahead and turn it on. Okay, we are on, and this is with the load. -22. -23 volts with the load. I'm going to turn it off and move over to the positive rail. Okay. And I'll go ahead and turn it on. And our positive rail is positive. So there you go. We should be good on our power supply now. So let me get this thing all hooked back up and see what we get. Power supply is now A-OK. Okay, guys, I put this all back together and I turned it on the monitor, and I was getting the exact same thing. The negative voltage was pulled down towards, you know, it was 7 volts or whatever. So the parts, the two Darlingtons are probably good, and regardless, those transistors are better than those, so I'm happy about that anyway. But what it's looking like is something on this deflection board is killing the negative voltage. So there's a bad part on here, I believe. So I'm going to have to go through, now that I've gotten all of that other stuff out of my head that it can be, now I know it's this board. There's something on this board that's not right. So I think something on the negative voltage rail is pulling it towards ground is what I think is going on. So I will go over the schematic, get the schematic out and follow that negative rail and find out what is leaking to ground. First thing I think I might do, actually I don't think it's a deflection transistor. I think it's like a cap or something like that. One of these caps or something is leaking to ground. Could be a diode. Yeah, there's something like that. So I'm going to investigate. I really don't think. I mean, it could be one of the PNP transistors. I could remove the PNP transistors. I know the NPNs are fine because they deal with positive voltage. The negative voltage goes to the PNP transistors. So I could just pull those out of the board and test them completely out of circuit. And we'll hunt down what's pulling this thing short. So yeah, we'll figure it out. But yeah, I got the gun heating up. I think I'm gonna take a minute, go grab a little lunch, and then come back with this. Well, after a lot of sitting around and scratching my head and trying to figure out what is going on with this thing, I finally figured it out. Let me see if I can zoom in, because it's not, I can't see it with my eyes. Come on, focus. Do you see that broken? There is no continuity. I have continuity from here to here, but there's no continuity from here to here at all. I'll show you that. Let me kind of try to, you know what, let me get the tripod. Okay, I got you set up for ohms there, and I'm going to be from the negative side of the minus voltage cap and to that resistor. You can see we do have continuity there. But now I'm going to go from that little bit of track from the resistor to the collector, and there's no continuity at all. Nothing. Goodness gracious. I mean, it's good that it just completely failed, because all of a sudden I was getting no output. You remember how I was getting a weak output on negative voltage? All of a sudden it went to no output, and I was like, what is going on? So I turned this around. I had it plugged in, and I can do this right now. Let me turn it on. Okay, it is on. Now I'm going to go ahead and show you across the minus 30 volt cap. Oh, I'm on ohms. I was like, what's going on now? Okay, let's try that again. This is across the negative cap. There you go. 42 volts. Negative 42 volts. And then if I come up to the collector, which the negative filter part of that filter cap goes straight to the collector of the pass transistor. And I come up here to the pass transistor, and there's 26 volts right now. Yeah, 26 volts. It should be 42 volts. It should be straight through. And I've got 42 volts because there's, if I go from, now let me turn it back off, okay? And I'm going to go back to ohms. If I go straight from the filter to the collector, it's like 1.5 mega ohms or something. No, it's open. Yeah, see, 1.5 mega ohms now. So there is little continuity there. There's a little bit of continuity there, but there's, there should be complete continuity. It should be a dead short, but yeah, so that's the problem. I'm just going to put a little jumper on there from this resistor. I'm going to put a little jumper from this resistor right here. I was measuring across the cap, and then to here I got perfect continuity, but I got no continuity from here to here. So I'm just going to put a little jumper right there, and we should be good to go. Goodness gracious. And there is your fix. Solder that to there, and then that to there, and to there. Now we have 100% continuity. So this thing should be good to go now. So I'm going to go ahead and try it out with the load, see what we get. Alright, I've got the load hooked up to it, and we'll go ahead and fire it up. And there it is, 24.84. So that is, it's a 22 ohm load, so that is just over an amp of draw on the negative line. So good. Now just to check, I'll go ahead and hook up the whatchamacallit, the positive rail. So go ahead, and I got that hooked up, turn it on. Once again, this is just over an amp of draw, and we have 26. So this power supply should be good now. There we go. Turned it off, and I'm going to try hooking it back up. Man, that thing gets so hot. Pushing, running an amp through that little resistor just gets it so hot. So cool. This thing should be good now for the duration. So yeah, let's go ahead and hook that up and see what we get. Alright, I got my little vector monitor out, and I had to remove the high voltage cage because this is a later version Electrohome. And I put the high voltage cage over there, and then I just kind of got everything else laying around. But it's all hooked up, and you will see it is working, but there is I don't know if you can see that or not. I'm going to go turn the light off. Yeah, let's turn the light off, and then you can see better that it's... Whoa. See how you can barely see the other stuff? There's got to be a Z amplification problem on this thing. You can barely see it. So that should be the intensity of the asteroids and everything. So yeah, let me go turn the light back on. Try not to stumble over anything. Oh. Whoa, whoa, whoa. All right. Yeah, so there's a intensity issue. No big deal. I had this hooked up to a different monitor. I don't know if you can tell, but it's really solid as far as the graphics. The deflection and the vectors are great, no problem. But when I had this thing hooked up to just a different monitor, I had just a tube, a 19-inch tube. The tube was a lot better than this one. You could actually see the asteroids and everything. This is not a very good tube. But it was kind of wavy and wiggly because all I had was the tube. There was no grounding. So, yeah, it didn't like that. But this looks good. You can't really tell in the camera. It's not wavy at all. It's stable. But, yeah, we have to deal with this Z amplification issue. And just look at that Z circuit, because it's not right. So, all right. That's next. All right. I don't remember quite where we last left off, but we are to the point where I have this monitor up. And you can see it's very dim. So I believe we have a Z amplifier issue on the deflection board or the monitor, period, somehow. Yeah. So, first thing I want to do, I've got the schematic for the Z amp right here. First thing I want to do is check and make sure we have our 90 volts coming in. And these transistors are good. I've tested them. So there's some diodes in the mix. Like the 90 volts goes through this diode right here. So there's current going through there. And we've got to make sure that's good. This cap I have replaced. That's good. Contrast. And these two pots, I think they're okay. I don't know for sure, but I can measure some voltage areas, and I'll make sure I got this hooked up right? Check those voltages. Grid 1, I believe, should be 50 volts. No, that's brightness. Yeah. This coming through is 3.3K, 1 watt. And that goes off to the cathode. So the cathode looks like it has 90 volts or whatever on it. Maybe 80 volts, 75 volts, something like that. Maybe the cathode is 50 volts. I don't know. I'm not a monitor expert. But I'm going to start just doing some testaruski-ing. Testaruski. And maybe these signals aren't quite right coming in through these caps and stuff. I don't know. And we can check some voltages right there. Just make sure all the voltages are there. That's probably the first thing to do. So I'll go ahead and do that, and I'll report back if I find something weird. Or maybe I'll just put the camera up on the tripod and do a little free recording, testing some voltages and see what happens. Alright, see what we got. Let's see what we get. This is ground, so I can try to just ground this like this maybe. It'd be cool if I could, but it doesn't look like I'll be able to. No. maybe. Let's see. Let's go diode to ground. There we go. We're grounded. Okay. Where's that 90 volts coming in? P700, which is right there. Pin 6. Pin 6. Yeah, pin 6. "96 volts DC." So that's good. That means our high voltage supply is working good. Okay. Where is D509? Right here. On the cathode, we should have that 96 volts. And we should have, what, 90 some volts on the other side? We do. Okay. Green. Let me just take a look at this really quick. I'm going to make sure that I got this hooked up correctly. The grid is pin 3. So I've got the grid going to one. That's 5, right? 5, 4, 3, 5, 6. That must be 6. 6 is a key. Can't see. Let me come back. I got to figure out what's going on with this. Okay, yeah. I think the cathode, or the grid, I think grid 1 should be 50 volts on this thing. And it's coming up 40, and it's maxed out at 40. And the brightness adjusts that. I'm pretty sure this monitor grid is 50 volts. So I think something's up with this. Why is there 40 volts there? I think that's supposed to be 50. I think. The cathode is what? That's pin 2. "90 volts. Okay, yeah, that makes sense. So it looks like the brightness is where we have a 620 ohm resistor. Very weird. Weird. Okay. .6 of a volt here. That basically is biasing, turning on this transistor, which is, the collector has the cathode output, which is right there. You gotta be careful not to be shorting anything on there. You blow something up. Okay. The Z input goes to the base of that. Yeah, you can get on a scope and view that. Yeah, 94 volts, and that is right here. That is emitter base collector. Yeah. So that would be easy to view with an oscilloscope. Is the tab of this transistor is the cathode, is the cathode input to the CRT. So that would be kind of easy to look at. The cathode and the grid. Filament G1, G2. Alright, anyway, I'm just kind of messing around here. I'm curious about this pot, and it looks like it may have been replaced. I want to make sure that this is the proper value. And let's look at this pot. This should be a maximum. You should be able to get 50 volts on G1, I would think. And the max I can get is 40. It's kind of concerning me right now. So I'm going to go ahead and turn this off, take the deflection board out, and start looking at that. See what we got going on here. Because, yeah, all you can see is when the ships come out and fire bullets. You cannot see the asteroids. So, yeah. We have a brightness issue. So let me go ahead and take this thing apart and see what happens. Okay, let's play with pots. I'm going to zoom in to this and we'll look at the meter. This is the OG pot 500K for the brightness control. It's a 500K pot. I'm going to put my leads across the entire pot. So let's measure the entire resistance of the pot. 557K, that's fine. You know, it's pretty close. Okay. Now, how this works is we need this to go to 0. The less resistance on the pot, the higher the brightness, right? That's how this works. So if this is, okay, let's go up to 500, the 500K side. So we have the wiper all the way to one side and we're getting 544K. So that's good. Now when we take it all the way, the one-turn pot all the way to the other side, it should go to 0 or close to it. So we're moving and it's tracking well. Looks okay. We are about halfway now and it's 250-ish K. And continuing down. And about 100K now. And continuing down, and now we have hit the end of the travel. And we still have 16K of resistance at this end of this pot. This should go close to 0. It should go 0 to 500K. 16K is still a lot of resistance, and that is why we're not getting up to 50 volts on the brightness. If I put a different 500K pot on and measure across it first, this is brand new pot, 500K. and we get 460K, which is fine. And now we'll go to one edge, or we'll go to the wiper, and I'm right smack dab in the middle of the travel. So I'll go all the way to the high side, and we're at 460K. And as I go all the way to the other side, now we're back to center, 250K, and continue on. And now we're 90 degrees-ish, 75 ohms, and we should go close to zero. And this is the end of the travel right here, 8 ohms. 8 ohms and 16K ohms is a big difference. So that's going to be our problem, is the pot. And this is the contrast pot, which is a 500 ohm. And if I measure across it, this is the original one. 760 ohms, which is actually okay. It's high, obviously. But that wouldn't matter, because the closer we go to zero, the more contrast there's going to be. So this should track to zero. And right now we are on the, now it's saying over limit. Now it's saying 93 ohms. And now it's 120 ohms all the way to one side. And now that might have just been a bad connection. Okay, one side we're all the way up to 714 ohms, and the other way it should go to zero. And it goes down to about 120 ohms. That's as far down as it'll go. It's all the way pegged to one side now. 83 ohms. And it's kind of flaky-ish. I back it off a little bit, it goes down and then starts going up. And if I look at the other side of that pot, now this will be the high side of the travel. And if I go back the other way, we should get, see, I'm going back towards the upper, and it's 700 ohms, and as I go all the way to the end, it's going, I mean, it's almost 800 ohms. And all the way to the other end, we have, this end goes to 50 ohms. Let me put another pot on. This is a used pot. It's a 500 ohm pot. And if I go across it, it is 550 ohms. If I go to the wiper, see how far this goes to zero, how close it goes to zero. Here's the center. And it goes down to 20 some ohms. Now I'm going to grab a 200 ohm pot that I have that is new, and I'm going to look at how that tracks. Because remember, the high side of the ohms doesn't really matter. It's getting close to zero is what we need. Okay. Now I have a new 200 ohm pot, and let's go across that. Okay. And it's 173, which is kind of low. But let's see how far this tracks to zero, how close it tracks to zero. Okay. 70 all the way down to that close to 0 ohms. And let's check the other side of the pot. So this is now the high side. And it goes all the way to 0. So that's awesome. That's a 200 ohm pot. And that might not work. I wish I had a 500 ohm pot that was better for that. Let's see how far this one tracks. This is 500 ohms. And this one, that's kind of dead center. And it goes down to 11 ohms. Yeah, that'll be interesting. An interesting experiment to put that 200 ohm pot in place. That's what I'm going to do. I'm going to try this 200 ohm pot. This 500K pot is no good. That's going in the trash. I'm going to adapt this 500 ohm pot. It's a different footprint, but I'll have to adapt it. And this is the other 200 ohm pot which I'm replacing, or 500 ohm pot that I am going to replace. So let me replace those, put this thing back together and see what we get. Alright, and I got the 500K and 200 ohm. This is supposed to be 500, but we're going to try it with a 200. And you can adapt these kind of pots like this that go kind of into the board like that. Just kind of straighten the bottom legs and then run a little, just run a lead down, solder a lead to the wiper contact and run it down, solder it. So let's go ahead and put this thing back together and see what we get. Alright, well, I was kind of pulling my hair out a little bit over this. Like, why won't this thing work right? I figured it out. It was that pot. I just had to adjust the pot. I may replace that pot because it looks pretty beat up. I did do the caps on this board, but it's this adjustment right there. And it brightened it right up. Yeah, so. Alright, well that is it. I disabled the, I completely disabled the spot killer for some reason, even though the spot killer didn't have nothing to do with anything. Like I said, I was just confused. I was like, this should work. I tested all of the parts in this circuit and they were all good. I replaced this for no reason. And I'm going to put the original one back in it because this is not the right transistor. So I'm going to put and the other one tested perfectly fine, but I didn't know what else. Yeah, it was the pot on that. I'm going to replace that pot because it's ugly and the adjuster is broke off of it. So I am going to replace that little pot. Yeah, this is good and solid now. So happy about that. And you can actually see it. Alright, yeah, so I'll do that. I'll do that off camera. And this video, for all intents and purposes, is done. It's the Electrohome G05-801. Rebuilt the power supply, and there was a bad trace on there that was really messing with me. I got two really heavy duty Darlington amps on there. I got heavy duty deflection transistors on the heat sinks. I replaced all the preamps, which, yeah, I'm just going to leave it like that. The other ones were good. I just replaced them. with a little heavier duty preamp transistor. These pots were definitely no good. So we fixed that, replaced those. I'm going to put the original transistor back in here, put this, put the spot killer transistor back in it. And that's really it. Just kind of let it run. Okay, yeah, that's it, guys. Asteroids. So this customer, I repaired the board, the monitor, and the power supply. So yeah, I kind of wish that they would have sent the monitor all together so that I could, inspect the tube, because I've got some tubes over here that are junk. These two tubes on my tube, I put them on my tube tester. These two guys, and they are absolutely garbage. They have no life. This one comes up pretty good on my tester. So, yeah. And it's got a decent picture. It's not great. This tube is okay. It's really not great. But it is what it is. So, yeah. Okay, guys. That's it. So that's going to do it for this one, and we'll see you on the next Classic Arcade Repair. Bye for now, everyone. And just as a footnote to this video, a couple of things. Number one, I got tired of lugging that big transistor thing around, so I made, it's not that hot. It's not really hot at all. That one's a little warm. That one is definitely warmer. It's not even hot though. It's warm. This one, not so much. So this must be the Y deflection circuit over here. And this must be the X deflection circuit. Because the X deflection circuit works harder than the Y. Makes sense, it's longer this way, right? But I had this old tube. I just got this tube out. It's kind of just propped up. It was really bad and squiggly because it was no ground, nothing was grounded. So I put a little ground on it. You see, just a wire across there, and then I'm running it all to the ground right there. So everything's grounded, so it's pretty stable. Looks good. Yeah. But I'm using tip 35 and tip 36 transistors on here. PNP and PN pair. I just drilled and tapped these aluminum heat sinks. So for doing repairs, I got portable deflection amps, to plug into these boards. Pretty cool. And I can just bring this tube out whenever I need to test. Looks good. Alright guys, now we're going to call it good. This baby is redone. Okay, we'll see you next time.